Hello to everyone and welcome on the YouTube channel School for All. So today we are starting with a new chapter, Project Management. So as usual, we are not coming here to tell stories, so I'm going to give you the important points you need to know for you to answer past questions with confidence. Good. Now, when we talk about project management, so these are the different things you need to know concerning the chapter. So you cannot be studying a chapter, project management, without knowing the definition of a project. So the first thing you need to know in this chapter is the definition of a project. Good. So I think everybody knows what is a project. Like, let us say today I want to construct a house. So you have seen that building a house is a project. And generally to construct a house, it's made up of multiple steps, like different tasks I'm supposed to execute, in fact. And at the end, after completing all the different tasks, in fact, I will be done with the construction of my house. So from there, what is the definition of a project? So a project is a sequence of tasks that must be completed within a specific period of time to achieve a particular goal. If your project is to construct a house, your house is made up of, the process of construction is made up of multiple tasks. Good. So by the time you are going to execute each of the different tasks, when you are done with all of the different tasks, you are okay with the construction. So this is the definition of a project. The next thing you need to know after knowing the definition is how to represent a project. Good. Like, what are some of the tools? So let me just write it here. Tools used to represent a project. Good. So there are so many of them, in fact, that exist. So we are going to study just two types here. So this is what we call the Gantt chart, and this is what we call the PERT chart. PERT chart. Good. So these are the most popular tools used to represent a project. So the next thing is you need to know the definition. What is a Gantt chart and what is a PERT chart? So here, as usual, you are not coming anything. No. From the visual representation of a Gantt chart and from the visual representation of a PERT chart, you will come out with the definition. Take note. Good. Now let me just try to illustrate something here. So I think I will clean this definition. Make sure to pause the video and copy. Now let me clean this. Okay, so this is a visual representation of a Gantt chart, and this is a visual representation of the PERT chart. At least you must have this visual representation in mind so that the definition becomes very easy for you. So what's a Gantt chart? So generally in math, people have what we call bar chart. Good. And we have different types of bar charts. Here, this is a vertical bar chart, and it's another type of bar chart we call horizontal bar chart, where the bar are drawn like this, horizontally. Good. So when you are defining a Gantt chart, the first thing, in fact, before defining Gantt chart or PERT chart, you need to know that both are tools used to represent a project. Good. Used to visually represent a project. Now, coming to Gantt chart. So in the exam, they cannot ask what's a Gantt chart. They just say it's a tool used to visually represent a project. You have one mark there because the definition you are given is the same definition for PERT chart. So when you are defining them, you need to differentiate between a Gantt chart and a PERT chart. So the definition of this one is clear. A Gantt chart is a horizontal bar chart used to represent a project where tasks are represented on the vertical axis and durations are represented on the horizontal axis. Exactly that. Or another person will say a Gantt chart is a horizontal bar chart used to represent a project where tasks are represented on the y-axis, like in math, and duration of each task are represented on the x-axis. So you have seen that when you are giving the definition, you are understanding what you are saying. Now, coming to the PERT chart, it's very clear that you cannot be talking about Gantt chart or something here, or horizontal bar chart, or I don't know, vertical bar chart. No. Here we are having something else. So here you realize that here you have multiple nodes connected together. So this is a network diagram because you are realizing that you have different elements interconnected together. And this network diagram is what we call a graph, like this. So when you are defining PERT chart, you'll be saying that a PERT chart is a graph network diagram used to represent a project where tasks are represented using nodes, and durations are represented using arrows, as you have seen here. Like here, this task A. So this line, the arrow starting from A to B, is representing the duration of task A. Take note. So A here is taking how many days before completing? 4 days. B is taking 2 days. C, I've not indicated the time of for C. So C, let me just say, I don't know, 3 days. Take note of that. So this is how we represent a project with a PERT chart. So the definition here is very easy and very clear. So I will repeat it for the last time. A PERT chart is a network diagram, or you say a graph network diagram. Let me just write it somewhere. So it's clear, a PERT chart is a graph network diagram used to represent a project where tasks are represented using nodes. This is the circle here represents the nodes, and duration using arrows. Take note of that. Very easy. Now let us move at the level of a Gantt chart. So the same thing. So let me just write it somewhere. Perfect. So a Gantt chart, it is a horizontal bar chart used to represent a project where where tasks are represented on the y-axis, or you say the vertical axis, and duration of each task, because if you realize that this is a task here, so from here to here represent the duration of that task, and so on and so forth. So duration of each task on the x-axis, or you say the horizontal axis. Good. So I think this is all for the definition of Gantt chart and PERT chart. Now the next thing that I've not mentioned here is, what is the full meaning of PERT? Because they asked that in the exam, June 23. They are asking the full meaning of PERT. So let me just write it here. So PERT simply means Program Evaluation Review Technique. Good. So in some textbook, you will see Program Evaluation Revision. Either you see review or you see revision technique is the same thing. So please never forget this. Now, the next thing, after knowing the definition of a Gantt chart and the PERT chart, there are some definitions you need to know, because the definition will help you to answer past GCE questions. So remember that we are exactly GCE oriented. So let me clean this and we continue. The first definition that you're supposed to know, because we have a total of 5 definitions here, minimum, that you're supposed to know. Now let us start with the first one, a dependent task. Good. Now, at this level, for each understanding definition is very clear. Imagine that I'm having a task here called task A, I'm having another task B, and the duration of task A is 5 days. Good, 5 days. So what happens here is, when A will complete its execution, B will start its own execution. So you realize that B depends on task A. B depends on task A. Why? Because A must complete first before B can start, because as you are seeing the arrow here, it's very clear. This A taking 5 days. So when A ends somewhere here, so this day 5 somewhere here, B can start. So we call B a dependent task. So what is a dependent task from this? It's very easy. A dependent task is a task that can start when the previous task has completed its execution. Or another person will say, a dependent task is a task that can start when the predecessor task has finished its execution, has completed its execution. When the predecessor task. Good. Take note of that. So that's the definition of dependent task. Let me just write it very fast. Good. So dependent task, it is a task that can start when its predecessor task has completed. Good. Because you can have multiple predecessors. You can have this situation where you have task A here, you have task B, then you have C here. Good. So what happens here is, this is showing that C depends both on A and B. So you can depend on multiple tasks. And if you are depending on multiple tasks, it simply means that they must finish their execution before you can start. That is why the level of definition I'm using plurals here. Good. So take note of this. So we are done with dependent tasks. So the next now is number 2. Slack time, very, very important. So there's no question on project management that you will see, in fact, where they're not asking what is the slack time, or maybe calculate the slack time from a PERT chart or a Gantt chart. So let us get the definition. Let me just write it first before I explain. Good. It is the amount of time a task can delay without delaying the entire project. Take note. So let me just explain that using this diagram. Now you realize that this is a project because you have a combination of tasks. Now under this project, the duration date of this project is 6 days. So this is the duration date. Meaning after day 6, we are done with the whole project. Now, from here you realize something. This task A needs how many days to complete? It needs 2 days. You see, so this day 1, day 2. Good. Now, task B needs 1 day to execute. Like he's supposed to start at day 3 and finish at day 4, and so on and so forth. Now, you realize something. Imagine that there's a small problem and task B decides to start at day 4. Since it needs just 1 day, it simply means that if he starts at day 4, he's supposed to complete at what? Day 5. So imagine that I clean this part like this. Now, so he start here at day 4 ending here. So this is what task B. Now, you realize something. That the fact that, this is, wow. Now you realize something. The fact that B is starting at day 4 and ending at day 5 is not affecting the duration date of the project. Like he's not extending the duration date of the project. So you have seen that here. It simply means that the slack time of B is what? One day. Good. So that amount of time that you can delay without delaying the entire project. Now let us take something like task G. You realize something. Task G needs 2 days to execute. Like he's starting at day 4, ending at day 6. Imagine that he delays for 1 day, than to start at day 4, he starts at day 5. If he's starting at day 5 and he needs 2 days, meaning that he'll be doing day 5 to day 6, then day 6 to day 7. Good, like this. Now, when you hear that, it's a problem because he's already extending the duration date of the project. The project was supposed to take 6 days, but now because of this delay, the project will take 7 days. So you are seeing that G cannot have a slack time because he's extending the duration date of the project. He's delaying the project. Take note of that. Good. So make sure that when you're looking at slack time, make sure, in fact, that that time that you call slack time is not delaying the project. It's not affecting the end date of the project. By that moment, you'll know whether it is slack time or not. So after this, we're going to study something else and you understand it better. Critical part. Now, so what's the critical part? So the definition is very clear. It is the longest sequence. Good. So the critical part, it is the longest sequence of dependent tasks which determine the minimum time to complete a project. It's exactly that. Now, let me just illustrate critical parts from this diagram. Now, let me just draw this back. From this diagram, you realize something. Let us analyze the different parts that exist here. So here we have A. Good. This is the first step. Now, after A, we are going to realize that B depends on A and C depends on A. It simply means that either I move through the path A to B, or I move through the path A to C. Just that after A to B, is there any other task depending on B? Yes, this task G depending on B. If you look very well, see this line. Good, this is how you look dependency. Good, dependency simply means that after a particular task is done, immediately another task is starting. Meaning that task was depending on that previous task. Good. So it means that here the next person depending on B, so it's G. Good. Now, when you analyze, imagine that you are moving through the part C, like you are moving through this part A, C. After C, is any other task depending on C? No, because after C, there's no task that's starting here. We see that here, this way, the part is ending. So you realize here we have two parts. What is the duration of the first part? The duration of the first part is A take 2 days, B 1 day, and G 2 days. So duration is 2 plus 1 plus 2. So here the answer is 5 days. Now, for this other one here, duration is A, 2 days, plus how many days for C? 2 also. So it makes what? It makes 4 days. So the critical part is this one. Take note of that. So this is the critical part here. Why? So let us go to the definition again. It is the longest sequence of dependent tasks. Good. Remember that we are just looking dependent tasks. Good. Now, we determine the minimum time to complete a project. Some people will think that the minimum time here is 4. No. The minimum time is not 4 because at day 4, you are not completing the project. There's a task that moves to day 5 to day 6. Good. So when we are talking about minimum time to complete a project, we are simply talking about the time that you're supposed to complete the project without extension. Good. Because if this the minimum time here is 6 days, meaning that if everything moves well, there's no delay, there's no slack time, things like that, the project will end at day 6. This is what we call the minimum time to complete a project. But if there's any delay on a dependent task, it's going to extend the duration date of the project. But when we are looking critical part, we don't really care about that. We just concentrate on the minimum time to complete. And that minimum time is coming from the longest part. Why? Because you realize that by the moment I'm executing task Z, Task C is already completing somewhere here. Good. Meaning that by the moment task J is still in execution, task C is already ending. Just to tell you that if you are taking this as a critical part, it's not as if these other tasks are not running in parallel. They are still running in parallel. So the critical part is just to make sure that the last task that we are going to execute is the last task of the project. Good. So that by the time you are executing this man, we are sure that we are done with the project. And it's exactly what you are seeing here. J is what? The last task. Good. So take note of this. Very, very important. Now, let me just take a small example to explain this. So imagine that you are three of you, this one person, another person, going to the restaurant. And generally, when you are going to that restaurant, let us say by the time you go at 8 a.m., you leave the restaurant maybe at 11 a.m. Good. So what happens here is, now let us say when you are moving to that restaurant, this person generally takes 30 minutes to complete its food, to finish with its food. And this person maybe takes 20 minutes to eat. This person takes 1 hour to eat. Good. So you realize that generally, if I'm asking what's the latest time you will leave the restaurant, or the minimum time you will leave that restaurant, if you are going to the restaurant at 10 a.m., you will give the answer 11 a.m. And why are you giving the answer 11 a.m.? Because you are taking into consideration that the person that will take the longest time possible to eat. Good. And the person is taking 1 hour. So the latest time, the minimum time you will leave the restaurant that you are giving to me is based on the person taking the longest time to eat in the restaurant. So here it's the same thing. Good. So critical part is what? It's the longest sequence of dependent tasks, but which determine the minimum time to complete a project. So I think from here everything is clear. So we are done with the definition of critical part. So we go to the next thing. Good. So after knowing what the critical part, the next definition here is lag time. So what's lag time? It's very easy. Let me just illustrate something first. Imagine that I'm having a task here called task A. I'm having another task here called task B. So you are seeing that task A is done here, but task B is taking a certain number of days before it starts its execution. So this amount of time that a task delays before starting after a previous task is done is what we call the lag time. So what is the definition? So let me just define it very fast. Good. And if I take a real life example, let us say you are in home construction. Task A is maybe, I don't know, building the wall of the house. So you are saying, let us say task B is maybe, I don't know, painting the wall. So you are seeing that by the moment you are done with the wall of the house, you cannot start the painting directly. No, you need to wait, I don't know, a small time first, a number of days, let me say it like that. You need to work a number of days before you start with the painting, which is task B. Good. Now, so this is exactly that. So lag time, it is good. So lag time, the amount of time a task delay after the completion of its predecessor. Good. Like if this task A, this task B. Good. So task A is the predecessor of task B. So this amount of time B delays before starting after the completion of its predecessor is what we call lag time. Take note of that. So we go to the next definition. The next is lead time. So we talk about lead time is very easy also. Now let me just draw something. Imagine that I'm having task A here, then task B somewhere here. Good. So you are seeing that the amount of time that a task can start before the end of its predecessor task is what we call the lag time. Good. So the amount of time a task can start before the end of its predecessor task, we call that the lead time, sorry, not the lag time. It's what we call the lead. Let me clean this. We call the lead time. Take note of that. So let me just write the definition very fast. Good. Amount of time a task can start before the end of its predecessor task. Take note. Now we go to the last definition. Good. So now milestone is very, very easy. So the milestone simply represents an important point in your project that shows its progress. Good. For example, let us say I'm building a house. Good. So a point like, I don't know, building the foundation. Maybe building the wall of the house. So all these are milestones because these are points that shows the evolution of your project. These are points that by the time you are done maybe with foundation, it's really showing an evolution of your project. It's showing a progress of your project. We call them milestones. Good. But let us say, I don't know, carrying bricks from one place to another in your construction. You are seeing that this is not a milestone. It's not showing any evolution. It's not showing any progress in your project. Take note of that. So the definition here is, let me just write it very fast. Good. It's an important point in a project that shows its progress. Take note of that. We see that shows its evolution. Perfect. So we are done. So this is all what you need to know concerning project management. In fact, these are the most important things you need to know concerning project management. So the next video we are going to work on past GCE question, whether you are doing ICT or you are doing a computer science ordinary level, because this chapter for the ICT student and ordinary level computer is similar and it's almost the same thing. Now, the type of question you're asking in ICT is not really the same type of question you'll be asking for the ordinary level student. Good. So if you have enjoyed the video, make sure to like the video and leave a positive comment, and see you in the next video for past GCE question under project management. Thank you.